Hello students, in this module we will see how to tackle the sums based on 1 upon a plus b sine 2x plus c cos 2x in a shortcut method from entrance point of view. In the earlier module we have already seen a type of the same, that is 1 upon a plus b sine x plus c cos x. Let us first look at the general forms. In this type what we can have is integrals of the form 1 upon a plus b sine 2x dx, 1 upon a plus b cos 2x dx, or 1 upon a plus b sine 2x plus c cos 2x dx. Integral of any of these has to be solved using a substitution, and that substitution is put tan x is equal to t. That is what we know. If I put tan x is t, x is tan inverse of t, and therefore we can say dx is dt upon 1 plus t square. My dear students, please make a note, the numerator does not have a 2 as compared to the earlier type. Now, in this case, sine 2x also has to be written in terms of t, and the value of sine 2x in terms of t is simple, 2t upon 1 plus t square, and that of cos 2x is 1 minus t square upon 1 plus t square. Now that we know all these values, how a general example can be converted or transformed, let's have a look at that. So let's take first the integral 1 upon a plus b sine 2x plus c cos 2x. Now my dear students, in this case, the numerator is dx. That will be replaced by dt upon 1 plus t square. In the denominator, let us keep the a as it is, the b as it is, and in place of sine 2x, let us put the value which is 2t upon 1 plus t square. In place of cos 2x, let us put the value 1 minus t square upon 1 plus t square. Now my dear students, after this, the step is obvious. We will take LCM. Now when we take LCM in the numerator, in place of dx, what I get is simply dt. That is, the numerator should be replaced by dt. Also, the constant term, which is a. Now, the constant term gets multiplied by 1 plus t square. So, that is what I need to remember. The coefficient of sine, that is b, gets multiplied by 2t, and the coefficient of cos, that is c, gets multiplied with 1 minus t square. And these are the things which I need to remember. That is, the numerator should be replaced by dt only. Constant term should be multiplied by 1 plus t square. Coefficient of sine should be multiplied by 2t, and coefficient of cos should be multiplied by 1 minus t square. Now let us apply this in an example. Let us see one question from the entrance point of view. It says, evaluate or which of these is the correct answer to the question 1 upon 5 plus 7 cos 2x. Now my dear students, this clearly belongs to the shortcut we discussed some time back. As per the shortcut, the numerator should be replaced by dt only. The constant term, which is 5, should be multiplied by 1 plus t square, and coefficient of cos should be multiplied by 1 minus t square, as it is. Now, what am I supposed to do? To simplify further, I need to open the brackets in the denominator. On opening the brackets, we get 5 plus 5t square plus 7 minus 7t square. Now, that gives me 12 minus 2t square in the denominator. So, let us write that dt upon 12 minus 2t square. Now, if I take a 2 common, what I'll get is 1 by 2 integral of. After taking 2 common, the first term in the denominator is 6, which I can write it as root of 6 the whole square. And likewise, that minus t square will be written as minus t the whole square. Correct? Now, this integral is of the form a square minus x square. When I say a square minus x square, the formula is 1 upon 2a log mod of a plus x. That is, the numerator should have a plus. The options a and c have a minus in the numerator, so they are not my answers. So either b or d is the answer. Let us see further. Now, as per the formula, I will have 1 upon 2a. Now be careful, 1 by 2 is already present, and 1 upon 2a means 1 upon 2 root 6. Now if you check, the constant here becomes 1 upon 4 root 6, which is present only in option B. Therefore, my correct answer is option B. I am not interested in the last part because it is same in both options B and D. Am I correct? Let's see one more example. Now the question here says, which of these is the correct answer to the question 1 upon 3 plus 2 sine 2x plus 4 cos 2x. Now my dear students, how do we solve this? Again, we call back our shortcut. Now this is what we have to do in this case. The numerator gets replaced by dt. The constant, which is 3, gets multiplied by 1 plus t square. Coefficient of sine 2x, which is 2, gets multiplied by 2t. And coefficient of cos, which is 4, gets multiplied by 1 minus t square. Now, to solve this further, we need to open the brackets in the denominator. So dt upon, can I say 3 plus 3t square plus 4t plus 4 minus 4t square. Now, if you see, students, this finally comes down to, I have a minus t square and then we have a 4t and a 7. So 7 plus 4t minus t square. Again, this sum becomes a sum of the perfect square method. Coefficient of t square cannot be negative. So in the next step, I take common from the last two terms, a minus common. So what we get is 7 minus of t square minus 4t. And spaces, I am sure you are also consensus with me that we need to add subtract 4. So that is what we have done here. Now when I do this, what I get here is 1 upon under root of, can I say 11 can be written as root 11 the whole square minus of t minus 2 the whole square. Is that okay, my dear students? Now these are the options in front of us. Let us see what is to be done. Now what we need to do is very simple. Apply the formula of 1 upon a square minus x square. When we apply the formula of 1 upon a square minus x square, what we have is 1 upon 2 root 11, which you can see is present in every option. Now further, log mod of. Now a plus x means root 11 plus t minus 2, that is tan x minus 2 upon root 11 minus tan x and minus of minus 2, therefore I write plus 2 and plus c. Now my dear students, this is present in option A. So the correct answer is nothing but option A. And that's all I have in this module, my dear students. Thank you very much.